Welcome to lesson 1 on 3 sets problem. Alright, so just as you can see on our slide, 3 sets has 8 regions. After we have drawn our 3 sets or Venn diagram for 3 sets, we should expect or we should get 8 regions. So I have numbered them from 1 to 8. In fact, the numbering of the region is not the same as I have done, or it doesn't follow the same pattern I've done. It can be numbered anyway. Someone can decide to start numbering from the region I have used 7. Right, so you can start numbering from this side. This can be your region 1. This can be your region 2. This can be your region 3. Any which way can be your region 1. Any one can be your region 2. I decided to number it like this. So we have region 1, region 2, region 3, region 4, 5, 6, 7, and then the one outside, the parts outside the circles. That is our region 8. In fact, in the next slide, we talk about each of the regions, so that wouldn't be a problem at all. Alright, so we have region 1 shaded. Over here, I've shaded region 1. How do we call region 1? The parts shaded region 1, if you look at it very well, it is found in only these parts of the circle A. It is not found in circle B. It is not found in circle C. It is found only in circle A. Right, the part shaded is found only in circle A. That is region 1. It's found only in circle A. It is not found in circle B. Neither is it found in circle C. Right, so because it is not found in circle B, it is not found in circle C, we say it is A only or only A. Mathematically, we say A intersection B complement intersection C complement. The complement means the one that is not found in it, right? And we know that the region 1 is not found in circle B. That is why it is B complement. It is also not found in circle C. That is why it is C complement. It is only found in circle A. So that is A only, which is mathematically written as A intersection B complement intersection C complement. Similarly, when we look at the region 2, when we look at region 2, this side is found only in B. Only in B. It is neither found in A nor C. The region 2 is found only in B. When you look at the whole circle of A, the region 2 is not found in A. The region 2 is not found in any parts of the circle C as well. So because it is found in only circle B but not circle A, not circle C, no part of region 2 is found in circle A, no part of region 2 is found in circle C. So we say only B or B only. Only B or B only. So A has nothing to do with region 2, which means A will have a complement. C also has nothing to do with region 2, so it will also have a complement. But it is found in B, so B will not have a complement. So the one that the region is found in doesn't have the complement, but the ones that the region is not found in has the complement. So over here, if I am writing it mathematically or I am saying it mathematically, it's going to be A complement intersection B intersection C complement. You could have written B intersection A complement intersection C complement, but it's advisable we write it in order, right? A comes before B, before C. So it is region 2 is not found in A, it's not found in C. So A and C will have the complement. So A complement, intersection B, intersection C, complement. That is the region 2. Similarly, the region 3, this side, is also not found in circle A, is not found in circle B, meaning circle A and circle B have nothing to do with region 3. That is, they are going to have complement, while C doesn't have a complement. So if I should write this mathematically, it's going to be A complement, intersection B complement, intersection C. Because the 3 is found in C, it is not going to have a complement. But then because it is not found in A and B are going to have complement. And again, like I said, the complement means the ones that are not found in, right? So 3 is not found in A, so A is going to have a complement. 3 is not found in B, so B is going to have a complement. So mathematically, C only, which is the region 3, is written as A complement, intersection B complement, intersection C. All right. Then we move to the next slide. Now, looking at this slide, I have shaded the whole circle for A. The whole circle A has been shaded. What does it mean? It means that that very circle has nothing like only. Okay, I've shaded the whole circle. When you look at the circle very well, it comprises 4 parts or 4 regions: region 1, region 4, region 7, and region 6. So when we add all these regions, region 1, region 4, region 7, and region 6, we are going to get A. It doesn't have only attached to it. It's going to have A. Now, when we go back to the previous one, see where 1 is, or region 1, where I've shaded red, you can see that part is at only one side of A. At only one side of A. And then that side is not found in B. It is not found in C. So region 1 is not found in A, is not found in C. So we say A only. But with this one, region 1, region 1, region 4, region 7, and region 6 are all shaded. Meaning, when I add region 1, region 4, region 7, and region 6, it should give me the whole circle of A. It should give me the whole circle of A. That is right. Now, similarly, when I look at the whole circle of B, we can see that it comprises region 2, region 6, region 7, and region 5. So when we add region 2, region 6, region 7, and region 5, it should give us the whole circle of B. So if I'm given any word problem, I'm supposed to translate graphically, or I'm supposed to use a Venn diagram. And then we say 2 people read biology. You see, the question didn't mention only. It means that 2 is for the whole circle B. The whole of this circle is going to be the 2. Meaning that 2 is found in region 2, region 6, region 7, and region 5. When we add all of them, it gives us that 2. We will get there where we will see practical examples to do that. So for now, let's understand that B is the whole circle, which comprises region 2, region 6, region 7, and region 5. So when we add all those 4 regions, we will get the circle B. Similarly, when we add everything in the circle C, we get C. So 4 plus 7 plus 5 plus 3 is going to give us C. That is region 1. Sorry, that is region 4 plus region 7 plus region 5 plus region 3. All the 4 regions in this circle. All the 4 regions in the circle. When we add them, it should give us C. So C is region 4 plus region 7 plus region 5 plus region 3. That should give us C. Okay. Then let's look at where I have shaded again. Region 7. When we look at region 7 well, it is found in all 3 circles. It is found in circle A. It is found in circle B. And at the same time, it is found in circle C. Now, when you look at it very well, region 7 is found in all 3 circles. And we were told we have already learnt in 2 sets that the part that is found in both circles is called both A and B. But over here, we are looking at 3 circles. So the part that is found in all 3 circles is all A, B, and C. So we say mathematically A intersection B intersection C, meaning that part is found in A, it is found in B, and then it is found in C as well. So region 7 is A intersection B intersection C. It is found in all 3 circles. So region 7 is the intersection of all 3 circles. Intersection of all 3 circles. A intersection B intersection C. That is mathematically. All right. Now let's look at this very well. This very one plus I think the next slide or next 2 slides are a little bit complicated but very simple. So let's take our time and then pay attention here. Now you can see here that now I have shaded 2 regions. That is region 7 and region 5. I've shaded 2 regions, region 7 and region 5. When I add region 7 to region 5, it should give me B intersection C. It should give me B intersection C. So the shaded regions, that is region 7 and region 5. Region 7 plus region 5. If I add region 7 to region 5, I should get B intersection C. Now, when I look at this very well, I can begin to ask myself questions. The part 7 or the region 7 is found in all 3 circles. The part 7 is found in circle A, is found in circle B, is found in circle C, just like we looked at in the previous slide. So why is it that region 7 is found in A, is found in B, is found in C as well? But then if we add it to 5, we are saying B intersection C. We are not adding A to it. It is very simple. This is how to identify B intersection C or A intersection B or C intersection B. This is how to identify. First, cover the region that is found in all 3, or cover the intersection of all. So in our case, intersection of all is the 7. Cover it. If I cover it, I've used a red pen to cover it. If I cover my region 7, let's look at what remains. What remains is region 5. Let's look at where region 5 is found. In which 2 circles is region 5 found? Region 5 is found in 2 circles, B and C. Right? It's found in B and C. It is not found in A, meaning after we have covered our 7, we check the remaining parts. In which 2 regions or in which two circles, can I find that region? So those two circles in which you can find that region becomes the answer. So after we have covered our intersection of all, which is 7, the region 5 is found in B and C. So we say the whole region 7 plus 5 is B intersection C. I'm coming again. It's very, very important. We are saying that looking at the part I have shaded, I've shaded two regions, region 7 and region 5. Region 7 is found in all three circles. But when I add region 7 to region 5, it's going to be B intersection C. Why is it going to be B intersection C? Because I can see that my region 7 is found in all three circles. So why is A not included? If I add A, if I say B intersection C intersection A, or in the ninth arrangement, A intersection B intersection C, then that is going to mean my intersection of all, which is this one. Right? But over here, we have added region 5 to it. How do you know that this is B intersection C, or A intersection B, or A intersection C? Understand that always two parts will be given. Two parts should be shaded before it qualifies to be B intersection C, or A intersection B, or A intersection C. Two parts will always be shaded if we are talking about shading. If you get to word problem 2, you know how it works. All right. So over here, I've shaded two regions, region 7 and region 5. This region over here has been shaded. We are saying that mathematically it is known as B intersection C. B intersection C. If I am reading, I will see something like B and C. B and C. Mind the words I'm using very well. Pay attention to the words I'm using. B and C. B intersection C. That is mathematically. If I am reading or I am saying it, I will say B and C. How do I know that A is not included? How do I know that these selected regions are only, let me not use only here, are B intersection C and not B intersection C intersection A, or not B intersection A, not A intersection C? First, shade or cover the intersection of all, or the part that is found in all three regions. All right, cover the part that is found in all three regions. Over here, our region 7 is found in all three circles. Region 7 is found in all three circles. It's found in circle A, it's found in circle B, it's found in circle C. So I have covered that region. Let's look at the remaining parts. The remaining part is only region 5, right? Yes, the remaining part is region 5. When we look at region 5 well, a good look at region 5 will show us that region 5 is found in B and C. It is not found in A. So because region 5 is found in B and C and not found in region A, after we have covered the intersection of all, so we say B intersection C. So first, cover the intersection of all. Look at the remaining parts, that region that remains. In which two circles is it found? In our case now, it is found in B and C. So we say B intersection C is the whole of this part, 7 plus 5, giving us B intersection C. I said when you are reading or when we are saying it, you will see something like B and C. All right, similarly, if I should add 7 to 4, I should add 7 to 4, 7 plus 4 should give me something. Let's look at what it will give us. First, let's cover our all, which is region 7. So if I cover the intersection of all, which is region 7, or the part that is found in all three circles over here, region 7. If I cover it, which part remains? The part that remains is region 4. I ask myself, in which two circles is region 4 found? A good look at it will tell me region 4 is found in circle A and circle C, meaning this very selected part 4 plus 7 should be A intersection C, because after covering our all, we realize that the remaining part, which is 4, is found in A and then C. So B is not included. Because the 4 is not found in B, after we have covered our 7, we say A intersection C. That is not only the 4 side. That is the 4 plus the intersection of all, which is our 7. That gives us A intersection C. So 4 plus 7, this side is A intersection C. In a like manner, if I should select this side, the selected regions, that is region 6 plus region 7, what do you think that will be? Yes, exactly. You got it right. If you didn't get it right too, no problem. You can take your time and then get it well. Now, region 6 plus region 7 should be A intersection B. Why? If I cover region 7, which is the intersection of all, so always, if you want to check, we cover the intersection of all. So after I've covered the intersection of all, what part remains? The part that remains is region 6. So I ask myself, in which two circles is region 6 found? A good look at it would let you know that 6 is found in circle A and then circle B, meaning 6 plus 7, which is region 6, plus region 7 is going to be A intersection B. Again, I repeat, A intersection B is addition of region 6 and region 7. A intersection C is the addition of region 4 and region 7. B intersection C is the addition of region 7 and region 5, or region 5 and region 7. It is not one part. Combination of the two or addition of the two will give us B intersection C, or A intersection B, or A intersection C. Then we go to the next slide. Look at this too. You can see that we have shaded only one part, only region 5. Now the previous slide had region 7 and region 5 shaded, and we said that is B intersection C, which is said to be B and C. B and C. I repeat, B and C, or B intersection C, or B and C, or both B and C. I'm using other words that can be used. So mathematically, it is B intersection C. But when you are reading, or when they are saying it, you hear something like, or you see something like B and C, or both B and C. So let us not forget. So region 7 and region 5 shaded B intersection C, B and C, both B and C. But when you look at this one, region 5 alone is shaded. Only region 5. Only region 5. Only region 5. So you can see that region 5 is not found in any parts of the circle A. It is not found in any part of the circle A. So over here we add only to it. The previous slide, because a portion of it, which is in 7, is found in A, we don't add A to it. We say B intersection C, or B and C, or both B and C. But with this slide, we can see that the 5 is not found in any part of A, or the shaded part is not found in any part of A, or no part of the shaded region is found in circle A. Meaning, mathematically, we say A complement intersection B complement. I've already said that the complement means it is not found in that part. So because region 5, the shaded region, is not found in circle A, or because no part of the shaded region is found in the circle A, it means A complements intersection B, intersection C, because the part labeled or the part shaded with blue color, region 5, is found in B and C. Let's look at the difference between the previous one and this one very carefully. It's very much important. This is the previous one. It has two regions, region 7 and region 5 shaded, and that is B and C, or both B and C, or B intersection C mathematically. Why don't we have only attached to it? We don't have only attached to it because a part of it, a part of the full side that has been shaded, a part is found in A, so we don't add only to it. But with this, no part is found in A, right? No part is found in A, so we add only to it. So when you are reading, you will see something like B and C only, or B intersection C only, or only B and C, or both B and C only. So this one always has only attached to it. And then mathematically, we say A complement representing the part that is not among. I've already said the only means it is not included. So A complement intersection B intersection C. So this is how we write it mathematically. So B and C only, or both B and C only, is represented mathematically as A complement intersection B intersection C, meaning B and C only. The complement is telling you that A is not part of it, B and C only. All right, so similarly, the parts shaded with red, that is region 6, will be A intersection B only. The only is very important. A intersection B only, because when you check it well, the parts shaded red, which is region 6, no part of it is found in C. No part of it is found in C. It is found only in the two circles A and B. It is found only in the two circles A and B. So because no part is found in C, we say A and B only, meaning the region 6 is found only in region A, in circle A and in circle B. So region 6, the part shaded with red, is A and B only, or both A and B only, or only A and B. The only is very much important. So when we are writing it mathematically, we are saying that when you check it well, the part shaded in red, or region 6, none of that part is found in C, meaning C gets a complement. So A intersection B intersection C complement, meaning the C is not part. The shaded region, none of the shaded region is found in circle C. That is why C has the complement. So mathematically, the shaded part, which is region region 6, is A intersection B intersection C only. A intersection B intersection C. Okay, let me come again. I realize that I've said something quite different from what I'm saying. So mathematically, the red side, region 6, is said as A intersection B intersection C complement. Okay, the one I just said, instead of the complement, I said only. Sorry for that. So A intersection B intersection C complement, because no part of the shaded region is found in C. So C gets a complement. All right. So if I am saying it, or when you are giving it as a word problem, you see something like A and B only, or A intersection B only, or only A and B, or both A and B only. So that is the difference between the previous one and this one. This one has only, because no part is found in C, or the all is not included, so we add only to it. But then the previous one, which has the all included, we don't have only. All right. Similarly, this part, region 4, is A intersection C only, or only A intersection C, or A and C only, or only A and C, or both A and C only. Okay, what is very much important is the only I am saying, right? And then mathematically is going to be A intersection C intersection B complement, because the 4 is not found in circle B. So A intersection C intersection B complement. All right, but because we have to write it accordingly, right? A comes before B before C, so it becomes A intersection B complement intersection C. All right. And then the final region, region 8. Region 8. We can see that region 8 is found in none of the 3 circles. And we said when it is not found in the circle, it becomes a complement. Right? So because region 8 is not found in any of the 3 circles, each one of them gets a complement. So region 8, where I've shaded with yellow, is A complement, meaning it is not found in circle A. Is B complement, meaning we don't find it in circle B. And then C complement, meaning it is not found in circle C. So A complement intersection B complement intersection C complement. A complement intersection B complement intersection C complement. That is the part we have shaded. It means it is not found in any of the 3 regions. Complement. So something like when you are reading, you hear something like, or see something like, maybe 5 students read none of the 3 subjects. 5 students play none of the 3 games. Right? None of the 3 games. Or 2 students play neither football nor volleyball nor basketball, meaning none of them, so it comes outside. All right, now there are times too they will use certain words to let you know that the region outside the region 8 is 0, meaning there is no one in the region 8. Something like every student plays at least one of the 3 games. It means there is no complement. Every student reads at least one of the 3 subjects, meaning there is no complement. Complement is 0. Now, this very one can be written in another way we call De Morgan's law. A man called De Morgan's brought a law which works. So maybe in another video we look at how the De Morgan's law works. It is not only for 3 sets, but then this is how it looks like. It says that when you look over here, A intersection A complement intersection B complement intersection C complement. De Morgan's law says that it can be written as A union B, union C, all complements. So with that one, the complement comes out after we have put everything in parentheses. Meaning, if we want to make it union, we put everything into parentheses and then the complement comes out. If we want to make it intersection, it is A complement intersection B complement intersection C complement, representing those outside region 8. So if you want to use the complement individually, A will get its own complement, B will get its own complement, C will get its own complement. Then we use intersection, right? Or whenever we are using intersection, meaning each letter should get its complement. But if you want to make it union, A union B union C, then the complement should come outside. So we put everything in parentheses, then the complement comes out. So if you want to make it union, put A union B union C in one parenthesis and then the complement comes out. That is that. And this is the same as A complement intersection B complement intersection C complement. That is De Morgan's law. Maybe we'll look at it in another video. Okay, now that we are done with all the 8 regions, I think it's time we look at examples. This first lesson has 2 examples. So after looking at those 2 examples, I'd want to believe that when you get any question about 3 sets, you'll be able to answer. But this wouldn't be the end of the videos about 3 sets. I will maybe add about 2 or 3 other videos, right? Because of how the questions can sometimes be put to disturb you. Yes, something just came into mind. So quickly, let me talk about that before we come to the examples. Now, where the 5 is found, which we are saying is A intersection B intersection C complement. That is both B and C only. When we say the 4 side, it means both A and C only. When we go to region 6, it is both A and B only. Sometimes they will try to confuse you. So the parts shaded blue, region 5, we can also say it to be B and C but not A. B and C but not A. So if it is maybe a subject, 5 students read biology and chemistry but not agric, meaning take the whole of the agric circle. The part we are talking about shouldn't be in that circle. So the whole of this is the agric circle. And you can see that the 5 is not found in the agric circle. So we say that this very one can be said as B and C but not A. B and C but not A, meaning take the A circle out. So B and C only, or both B and C only, can be said as B and C but not A. You know that when we take A out, it means there is an only, right? B and C but not A. We are talking about 3 letters, A, B, and C. And then the question is saying B and C but not A. You see, the question has taken one of the 3 circles out, meaning we are left with only 2 circles. So only B and C. B and C but not A is the same as only B and C. All right. So our examples. So first example, or example 1. Out of 120 students in a school, 41 take French, 47 take economics, and 42 take geography. 14 students take French and economics, 15 take French and geography, 19 take economics and geography, and 8 students take all 3 subjects. Illustrate this information on a Venn diagram. Okay, so I advise you write this question again, because when I move to the next slide, this question is going to disappear, and it is this question we are going to solve. So I advise you pause the video, you write the question. When you are done, you resume the video. Same applies to example 2. All right, now before the next slide appears, I want to tell you something. Whenever you get the set problem, the first thing I advise is that get your universal, okay, the one that comes outside the rectangle. Get your universal. Over here, our universal is going to be 120, because that is the total number of students, right? So get your total number of students. After you have got your total number of students, which is the universal or the union of all the circles or all the things we are talking about, after you've got them, now look for the full circles. So representing A, B, and C, we are saying look for the full A, you look for B, you look for C, before you go to all 3 subjects. Over here, subjects, so I'll say subjects. All 3 subjects, the part that is found in all the 3. So first, look for your universal, the total. Second, look for the full circles. Look for the full circles. Third, look for the intersection of all the 3 circles, or the number of students who read all the 3 subjects. Then third, you come to those who read 2 subjects. Not only 2 subjects, but those who read 2 subjects. Then you come to only 2 subjects. Then you come to only 1 subject. So all, that is the total, the universal. Then you come to the full circles, and then you come to 2 subjects. Then you come to only 2 subjects. Then you come to only 1 subject. In fact, I missed the all 3 subjects. Yes, so all 3 subjects before you move on. Don't worry, the next slide comes and you understand what I am saying. So we are answering this question. I'm reading the question again. It says, out of 120 students in a school. So this is the first one I'm saying look for. That is our universal. Out of 120 students in a school. So we look for our universal. We have seen that. 41 take French. So I'm saying the next one after your universal is look for these full circles. So look for this circle, look for this circle, and then look for this circle. All right. So we are saying look for those who take French, which is this circle. Look for the students who take economics, which is this circle. And then look for the students who take geography, which is this circle, before you move on. All right. It says that 41 take French. So we have written it here. The question didn't say French only. If the question had said French only, then it would have been at only this side, which we looked at region 1. Okay. But the question said French, meaning the whole circle. Let us not forget, we said when we add this side to this side to this side to this side, it should give us the full circle. So French is the full circle. So it says 41 take French. So we have put it over here. 47 take economics. So we put it over here. It doesn't have only economics, so we put it there. And 42 take geography. So we put it here, or geography. We put it there. All right. Then we move on. But before we move on, I advise you write it like I have written. N into parenthesis F equals 41. N into parenthesis E equals 47. What it means is number of F is equal to 41. That is, number of students who take French is equal to 41. Right? Let us not forget, equal means is. And then bracket, which we call it, but then it should be parenthesis, means of. Right? it means multiplication, and then of means multiplication. So number of students who read French, or number of French, is 41. We have two ways of writing that, right? But for now, let's look at this. Another time, we look at the next one. Don't write F is equal to 41. That is totally wrong. F is equal to 41. No. There's another way to write it, but that one you will not bring equal to. We'll look at that later. Okay, now that I have identified my full circles, I continue. Now I said after the full circle, look for the intersection of all. So I keep reading, and then I look for the intersection of all. All right, it says, let me start reading. Out of 120 students in a school, we have indicated that 41 take French, 47 take economics, and 42 take geography. 14 students take French and economics. 15 take French and geography. 19 take economics and geography. What are we looking for? We are looking for those who take all the three. Sometimes it will not be given, but you have to use an alphabet or a variable to represent, say, X or Y. Advice: if your A looks like 9, don't use A. If your Z looks like 2, don't use Z. If your O looks like 0, in fact, for O, don't use at all, because sometimes you are not able to differentiate between O and 0. Don't use O. You can use any alphabet, but then don't use the ones that will give you problems. So it's better you stick to X or Y. All right. So we are looking for all. If it has not been given, use X to represent before you move on. If any part is not given, you use a variable to represent. So when we keep reading our question, it says 8 students take all 3 subjects. 8 students take all 3 subjects, meaning the intersection of all is 8. So we indicate our 8. After we indicate our 8, which is the all, we come to 2. Not only 2, but 2. So French and geography, French and English, and then English and geography. That is the side. So we look for this side. All right. Then we look for this side. And then we look for this side. All right. Good. So that is all right. Let's move on. So before I get that side, I have to read the question again. It says 42 take geography. 14 students take French and economics. French and economics. Not French and economics only. French. This is French. This is economics. So if the question had said French and economics only, it would have been only this side. That is French and economics only, region 6. But the question said French and economics. So because it is French and economics, it is region 6 plus region 7. That is the whole of this side. French and economics. Meaning if I cover my all, I realize that the remaining part is in French and economics. So French and economics is the whole of this side. The question is saying that 14 students take French and economics, meaning the whole of the part I've used red is 14. But we already know that this side is 8. So if the whole thing is 14, and then this very part, the intersection of all is 8, how do we get this side? We subtract the 8 from 14. What we get is for only this side. Okay, so 14 minus 8 gives us 6. Then we continue. 15 take French and geography. So these are French, these are geography. So 15 students take French and geography. It didn't say only French and geography. So that is F intersection G. Right, F intersection G, French and geography. So if 15 take French and geography, and then this side is 8, how do you get this? It means 15 minus 8, which gives us 7. All right. 19 take economics and geography. Economics and geography. which is this side, the whole of this side. So if the whole of that side is 19 and this side is 8, meaning to get this side, we get 19 minus 8, which is 11. I hope you are following. If in a way you are confused, you can go back and then play it again. So where our 7 is found is only French and geography. But when we add the 8 to it, it becomes French and geography. Where our 6 is found is only French and economics. But if we add our 8, which is the all, intersection of all to it, it becomes French and economics. Where our 11 is found is only geography. But if we add 8, which is the intersection of all to it, it becomes where the 11 is found is only in economics and geography. So when we add the 8 to it, it becomes economics and geography. I'm telling it again. Where the 7 is found is only French and geography. If we add the 8 to it, that is the intersection of all to it, it becomes French and geography. Where our 6 is found is only French and economics. Only French and economics, because it's found in only the two circles, only the F and the E. But if we add the 8 to it, which is the intersection of all, it becomes French and economics. The only is gone. Where our 11 is found is only economics and geography. Only economics and geography, because it is found in only the two circles, economics and geography. But if we add the 8 to it, it becomes economics and geography. The only becomes or the only is gone when we add the 8 to it. All right, so let's move on. Now that we have identified that, we are supposed to identify the only French, only economics, and then only geography. We are saying that the whole of this circle, the whole of the French circle, should give us 41. That's what the question is saying. So if I know this side, I know this side, I know this side, it's easy to get this side, right? How do I do that? Maybe I can say let A represent. So the A plus the 6 plus the 8 plus the 7 should be equal to 41. So after I have finished and then I solve, I'll get my A. Same applies to this side. If I say B plus 6 plus 8 plus 11 should give me 47, right? So after solving, I'll get my B. Same applies to only geography. If it is C plus 7 plus 8 plus 11 should give me 42, because the whole circle is 42. So after solving, I will get what C is, right? So you can pause the video and solve. I have already done that, so you can pause the video and solve. This side plus, so this side plus 6 plus 8 plus 7 should give you 41. Similarly, with this circle, everything in 8, when you add them, should give you 47. Same here. If you add everything in this circle, it should give you 42, meaning you equate to that and then you solve. All right, so I have done that, and then here we go. So 20 plus 7 plus 8 plus 6 is equal to 41. So if you use B, and then if you use A here and then you solve, you should get 20. If you put B here and you solve, you should get 22. If you put C here and you solve, you should get 16, because 6 plus 6 plus 8 plus 11 plus 22 should give you 47, right? Same to the other circles. So that is the end of the example 1. That is the end of the example 1. So we take example 2. So same way, pause the video, you write the question down, because you keep referring to the question whilst we are on the next slide. In a senior high school, there are 100 174 students in Form 2. Of these, meaning out of the 174, that's what it means. Of these, 86 play table tennis, 84 play football, and 94 play volleyball. 30 play table tennis and volleyball, 34 play volleyball and football, and 42 play table tennis and football. Each student plays at least one of the 3 games, meaning our complement is 0 or there is no complement. Each student plays at least one of the 3 games. It means agrono obia db, right? Obia agrono b. Everyone got involved. Those who don't understand that language or the dialect I use, just forgive me. What it means is that everyone, obia agrono b means everyone got involved in the activities, meaning the complement is 0. Display these facts in a Venn diagram and find those who play all 3 games. Alright, so you pause it, you write the question, then we begin to answer. So this is our Venn diagram, not completed, of course. The first one is we are supposed to illustrate on a Venn diagram. So the first thing is to write your total, your universal. So number of u equals 174 according to the question. Then we look for the circles, right? The full circles. It says that in a senior high school there are 174. In a senior high school, there are 174 students in Form 2. In a senior high school, there are 174 students in Form 2, meaning our total is 174. Of these, 86 play table tennis. So 86 play table tennis. The question didn't say only, so you put it up there. 86 play table tennis. 84 play football. 84 play football. And 94 play volleyball. 94 play volleyball. So after that, we look for all the 3, right? It says 30 play table tennis and volleyball, 34 play volleyball and football, and 42 play table tennis and football. Each student plays at least one of the 3 games. It means we were not giving those who read all the 3. Because we were not giving those who read all the 3, we have to use a variable to represent, right? And that's what we are actually looking for. So we use a variable to represent. So say x. It continues to say, so taking it again, 84 play football and 94 play volleyball. 30 play table tennis and volleyball. There is no only. 30 play table tennis and volleyball. Table tennis, volleyball. So it's going to be this side. So the whole of this is 30. 30 play table tennis and volleyball. So if the whole of this side is 30, and then we know this side is x, this side is going to be 30 minus x. Then the next one says 34 play volleyball and football. So volleyball and football, that is the whole of this, 34. So if the whole of that is 34, and we know that the intersection of all is x, this side is going to be 34 minus x. Similarly, 42 play table tennis and football. Table tennis, football, that's going to be the whole of this side. So if the whole of that side is 42, and we know the intersection of all, which is this side, is x, then only this side is going to be 42 minus x. That is done in the next one. So our intersection of all is x, then we get the other sides. So if the whole of this side is 30, and then our intersection is x, only this side is going to be 30 minus x. Similarly, if the whole of this side, that is table tennis and football, is 42, and our intersection of all is x, then only football only table tennis and football is going to be 42 minus x. All right, same applies to this side. Okay, right. Now we have represented that. You can see I've used green colors to write A, B, and C. We were not given only only table tennis, only football, and only volleyball. We were not given, just like in the previous one I said, you can use variables to represent and solve to get that side. We have used variables. So only table tennis, we have used A, only football, B, only volleyball, C. Right. Now in the previous example, we can see that there were no variables here, right? So we could easily solve and get our 20 here, our 22 here, our 16 here. We could easily do our additions and subtractions. But over here, we already have x here. We already have x in here. So it's not easy to just look and write the answer here. So we use the variables to represent, then we solve them separately. So if you want to get our A, we add the whole of the circle and then we equate to 86 because the whole circle should give us 86. And that will give us A in terms of x. What it means is we will make A the subject, having x in our answer, which will help us to get x here, x here, x here, and then x here. So we can easily solve. Same applies to this circle. I want to do my B. I add everything in this circle. I equate to 84. Similarly, if I want to get only volleyball, which is my C, I add everything in this circle. I equate to 94, and that will give me my only volleyball, which is C. Right? It will not give me a straight value. It will give me in terms of x, where I will finally substitute and get everything. All right, so solving for A. So you can write this down, or you can draw this as you refer to, and then solve our A, B, and C. So A plus 42 minus x plus x plus 30 minus x should be equal to 86. That's what we are going to do on the next slide. Okay, so A plus 30 minus x, which is one region, plus x, the intersection of all, plus 42 minus x is equal to 86, the total. So we are only adding everything in the circle for table tennis. Then we equate to the total of table tennis. After that, we add everything in the circle for football. Then we equate same to the circle for volleyball. All right, so we can see that negative x has cancelled negative x. So if negative x cancels negative x, we are going to get A plus 30 plus 42 minus x is equal to 86, what we have done on the next line. All right, so 30 plus 42 is going to give us 72 minus the x equals 86. So A plus 72 minus x is equal to 86. Now we group like terms. So A should be equal to 86 minus 72, because it is positive, it crosses the equal sign, it becomes negative. And then the x is also negative, it crosses the equal sign, becomes positive. So grouping like terms, A should be equal to 86 minus 72 plus x. Now 86 minus 72 is 14, then our plus x. So A should be equal to 14 plus x. So where we see A, we put 14 plus x. Similarly, b plus 34 minus x plus 42 minus x is equal to 84. So negative x cancels positive x. So we are left with b plus 34 plus 42 minus x equals 84. 34 plus 42 should give us 76. Then our minus x is here is equal to 84. Then what do we do next? We group like terms. So b should be equal to 84 minus 76, because the 76 is positive, it crosses the equal sign, becomes negative. The x is negative, it crosses the equal sign, becomes positive. So b is equal to 84 minus 76 plus x. 84 minus 76 is 8. So b is equal to 8 plus x. Wherever we see b, we put x, 8 plus x. Similarly, we go to c. C plus 30 minus x plus 34 minus x equals 94. Negative x cancels positive x. We are left with c plus 30 plus 34 minus x equals 94. 30 plus 34 is 64. So c plus 64 minus x is equal to 94. So we group like terms, getting c is equal to 94 minus 64 plus x. And 94 minus 64 is 30. So 30 plus x, that is our c. Wherever we see c, we put 30 plus x. So we redraw our diagram and then we substitute over there. So our a is 14 plus x, our b is 8 plus x, and then our c is 30 plus x. All right, so now the question says we should find our x, that is those who read all the 3 subjects. So how do we do that? We add everything in the 3 circles plus the complement, but because the complement is 0, we will not add anything. But assuming we had the complement, we add everything in the 3 circles plus everything outside the 3 circles, then we equate to the total. So we just add everything, then we equate to the total. So 14 plus x, now we know our a to be 14 plus x, so we will not use a again. Same applies to b and c. 14 plus x plus 42 minus x plus 30 minus x plus 8 plus x plus 34 minus x plus 30 plus x should be equal to 174, and that is what we have here. So negative x cancels positive x, another negative x cancels positive x, another negative x cancels positive x. We are left with only one x. So we pick all the numbers: 14 plus 42 plus 30 plus another 30 plus 34 plus 8 plus the 1x left is equal to 174, and that is what we have over here. When we add everything, 14 plus 42 plus 30 plus another 30 plus 34 plus 8, it should give us 158, not 154. It should give us 158. So that was typing error. So when you add everything, it should give us 158, not 154. So we group like terms. X is equal to 174, then the 158, which I'm saying is not 154 but 158, crosses the equal sign and it becomes negative 158. So 174 minus 158 is equal to 16. So x is equal to 16 students. Let us not forget our unit, which is students. So therefore, 16 students play all 3 games. So that is the end of this question, which is also the end of this lesson. Thank you for your time. I believe you keep practicing even before the next video is out. You keep solving questions as I prepare the next video. All the best in your study.